1, 2, 3. Good evening, ladies and gentlemen. Welcome to the pre-event of IAGI Annual Scientific Meeting Convention and Exhibition 2024. My name is Tara, a geological engineering student at Bandung Institute of Technology, who will be your host for today. First of all, I would like to greet the head of PP IAGI, Bapak STJ Budi Santoso, and the head of IAGI Annual Scientific Meeting Balikpapan 2024, Bapak Hamzah Umar. Selamat malam Bapak Budi dan Bapak Hamzah.
Selamat malam, terima kasih.
Terima kasih Bapak sudah datang. I also would like to welcome our honorable guest speaker, Professor of Coastal Science at NTU Singapore, Professor Adam Douglas Switzer. Good evening, sir.
Good evening, everybody.
Thank you, sir, for coming. And not to forget to mention our moderator for tonight, Bapak Saaduddin, Lecturer Laboratory of Coastal and Ocean Dynamic of Hasanuddin University. Good evening, Pak Saaduddin.
Good evening, Tarania.
Thank you for coming, sir. Ladies and gentlemen, this invited session is a part of our virtual technical session series of IAGI Annual Scientific Meeting Convention and Exhibition 2024, which has already been held since July up until this month. So make sure to keep updated for the upcoming series. And the main topic of today's virtual technical session is the coastal dynamic and hazard in Southeast Asia. But before we begin tonight's event, let us sing our national anthem, Indonesia Raya. Video operator, time and screen is yours.
Bapak, dia saudara Tegit anaknya dia. Oh.
Thank you. With the spirit of unity and pride after singing our national anthem, I hope we are ready to proceed tonight's event with full of enthusiasm. So, ladies and gentlemen, we'd also like to invite and kindly remind you of our main event, the 53rd IAGI Annual Scientific Meeting, Convention, and Exhibition, which will take place in Balikpapan on 7th to 10th of October 2024. For further information, please refer to the details displayed on the screen below. Now I will present the rundown for today's event. We'll start the event with the opening of MC and singing the national anthem of Indonesia, which has been done earlier, followed by reading rundown and event guidelines. And the next session will be continued with the introduction of moderator and speaker, and then move to the main session, followed by Q&A and summary session. And finally, we come to the closing and photo session. And during the presentation, we kindly ask all attendees to mute their microphones, turn off their cameras, and engage in discussion only through the chat box. For the Q&A session, participants are welcome to use the raise hand feature to ask questions or discuss verbally, Or you can also use the format name_question for question to be read by the moderator in the chat box. And now we will introduce the moderator for tonight, Mr. Saaduddin. He completed his bachelor degrees in Bachelor of Physics Education of Makassar State University and completed his master's degree in Geophysics of Gajah Mada University. Currently, Mr. Saaduddin has a professional career as a lecturer at the Laboratory of Coastal and Ocean Dynamic at Hasanuddin University and has published various works related to his professional field. So without any further ado, let us welcome our moderator for tonight, Mr. Saaduddin. For Mr. Saaduddin, time and screen is yours.
Okay, thank you, MC Tarania, for inviting me as the moderator for this tonight's session. So, welcome everybody for this the virtual session as the event of the annual event of IAGI, which will be held in Kalimantan this month. Today, to this evening discussion, we will have Professor Adam Switzer from Earth Observatory of Singapore, Nanyang Technological University. What about the CV of the speaker? And the title for this evening session is Coastal Dynamic and Hazard in Southeast Asia. Talking about coastal hazard, it's not only about tsunami, but we will talking about the sea level rises and then storm surge and also erosion. And then why Southeast Asia? Because it is in this region there is an extensive coastline and then high exposure of the hazard, and then the vulnerability of the climate change because we are in the tropical area, and then dense population in coastal area or in the coastal region, particularly in Indonesia. We can say that we are in the top 5 of top 3 country which has the dense population. So this evening we will have Professor Adam Douglas Switzer. We will deliver the material and then to present about the coastal dynamics and hazard in Southeast Asia. Hi Adam, it is the several times we met actually.
Indeed, we've met many times. I'm very excited about talking to you tonight.
Yeah, so I think without further ado, we'll invite Professor Adam to deliver the material.
Okay, so if I could share my slides, please. So if you could stop sharing, I'll share.
I think you can share by yourself.
Betul atau tidaknya PDIP berlabuh ke koalisi Prabowo Gibran nantinya?
Okay, I'm hoping you can see that.
Yes, it is. Yes, we can see that.
Okay, and you don't have anything on the screen?
We can see your screen.
Just my screen. Okay, but you can't see the images on the side, right? There we go. Okay. Thank you very much for the invitation to come and talk to you tonight. I've got about a half an hour of material. I want to talk about a particular aspect of getting at coastal hazards and coastal dynamics, because I want to talk about the geological role, the idea of getting at the long view of coastal hazards. And so I've divided this talk into essentially 2 parts. The first part is really about collaboration and the idea that in order to get a long view of coastal hazards, you have to be open to the idea of working with others in other communities outside of the geological sciences. And So I think that's the first thing. And the second point that I'll make in the first half of the talk is that often when you engage in a project and start to do research on a project, it raises more questions than it answers. And so I'm going to talk about the lineage of some of the work that I've done in the South China Sea on tsunamis. I'm very much going to focus on tsunamis tonight, but I'm going to come back to this common theme of collaboration as we go through the session. And in particular, I'll start with the Palu tsunami in 2018, and then I will come back to that a little bit later on with some work that we've done in collaboration with our friends at Sarakwala University on the tsunami deposits from the 2018 event. And so let me get started on the long view. And I'm very happy to take questions at the end. I think we'll have about 10 to 15 minutes if time runs well. The first thing I want to talk about is this is an image of the Palu tsunami in Indonesia in 2018. And when I look at an event like this, and my research team looks at an event like this, we start to ask questions immediately. Where did the tsunami go? Where did it come from? Where did it go? Why did it go to where it went? How often do these things occur? Has it happened in the past? How big is this event compared to previous events? Could I ask people to make sure that they are muted? Thank you. So these are the sort of questions that come up straight away. And if we look at this image here, you can see that there's quite extensive damage from the tsunami near the coast. There's significant erosion in the bottom right-hand side of the image, but less erosion to the top of the image at the coastline. You can see there's been significant subsidence. We've got offshore infrastructure that was onshore is now in the intertidal zone, and a zone of damage that goes back a few hundred meters. But if you get to the left-hand side, top left of the image, most of the structures are relatively untouched. And so the question here is, where did the tsunami go? Where did it come from? Why did it not go so far inland compared to other tsunamis that we've seen in the past? And then the other question is, how often do these events occur and how big are they? And so to do that, the general theme of my research is to try and use an integrated approach. And so this is an image that I presented at the International Coastal Conference, Coastal Conference Engineering, Conference on Coastal Engineering in 2022. And the idea I'm trying to put forward here is that geological data sets are really important for getting back in deeper time when we're trying to look at hazard records. But there's a lot of things that we can do along the way and incorporate into our assessment of coastal hazards to build a more complete picture. So we have the instrumental data sets, and they often overlap with the historical data sets. We have archaeological data sets, and some of my colleagues at the Earth Observatory have done a lot of archaeological work, particularly in Aceh, looking at tsunamis. And then we have the idea of indigenous knowledge, people that have been living in the area for thousands of years that have handed down oral stories and oral histories. And then we get into the geological component, the geological data sets that may go back thousands of years. And from there, we're trying to work out how often these sort of events happen over time. And so if you have a recurrence interval of tsunamis, say like large tsunamis in the Aceh area, we have a recurrence interval around 400 years. And so we need to incorporate all of these data sets. There's nothing in the instrumental data set. There's very little in the historical data set. There's a bit of archaeological information about the precursor to the 2004 Indian Ocean tsunami. There's some indigenous knowledge, but it's primarily in other locations. And the geological data sets really started to come to the fore around 2008 to 2009. And so by incorporating this sort of integrated approach, we'll have a better understanding about coastal hazard recurrence intervals and how often these things happen through time. So I'm going to use a few examples. The idea of collaboration for me with people outside of the geosciences really came from this paper. So this is a paper that my master's student at the time, Annie Lau, wrote. in back in 2009. So 2008, 2009, and it was published in 2010. And here, all of the authors are geoscientists. And one of the things we learned very quickly as we were going through this, that if we were to work more closely with historians, this would have been a much, much easier exercise, because historians have a way about going about collecting archival data that we had to learn from scratch. And so we did it, and Annie produced a very good paper. This is a highly cited paper that is really asked a few questions about tsunami histories in the Northeast and South China Sea. And in this place, we're looking really at China and Taiwan, touching on a little bit in the northern part of the Philippines. But we had 15 different databases and more than 100 sources. We identified 205 events between the year 1076 and 2009. But if you look at that image on the bottom right-hand side, you can see that there's an event that's recorded around 1,000 years ago, and then there's not much until around 1200. And then you go through, and then obviously most of the valid events, the ones that are well known, occur from the mid-1900s. But one event in 1871, 1872 stood out as particularly notable. And this was an event that was reported in historical letters and in temple records on the southwest Taiwanese coast. And so it really raised the question of, okay, what do we know about these historical events? And so we have a number of historical events that we realize that are valid or probable, given the assessment that we did. And we could dig into that a little bit further. Now, you'll see a QR code there. For those of you that wish to get this paper, if you scan that QR code, you should go straight to the paper in Natural Hazards and Earth System Sciences. And it was the same with the diagram, the paper previously that I mentioned on the concept of an integrated approach. And so this raised the question, what happened in 1871, 1872 on the southwest Taiwanese coast? And this is what the southwest Taiwanese coast looks like now. This is Kaohsiung in Taiwan. Now, if a tsunami of 3 to 4 meters, which is what was in the historical record, was to occur today, this would be quite damaging to the coastal infrastructure and the coastal communities around places like Kaohsiung and those on the coast in southwest Taiwan. And so the question was, okay, we know that there's been a historical event, but what can we do to try and investigate it? We can look for a geological record. Well, the Taiwanese coast is pretty heavily modified, so that doesn't really happen. But we can dig a little bit deeper into the historical record and see what we can glean in terms of the information from the historical record to try to give us a better understanding. And so in this case, what we did is we looked at the wave heights along the Taiwanese coast, and we could tell that there were significant waves from Tainan in the central parts of western Taiwan, all the way down to Kenting in southern Taiwan. And the Chinese historical documents reported this disastrous flooding event. They said that large waves suddenly struck under clear skies and submerged all the villages nearby. This description really eliminates a storm, and Taiwan's experiencing a typhoon right now. But there's no storm, it's in clear skies. And they described in the records that the sea suddenly roared like thunder, the sea retreated quickly, exposing leaping fishes and shrimps. It has many characteristics of a tsunami in the description. But of course, they linked this with volcanism at the time. But none of the volcanoes in the area could have created this tsunami. But of course, remember, this is 1781. This is pre-plate tectonics. And everything associated with earthquakes was associated also with volcanism at the time. And that was the common sort of thinking. So the question is, okay, we have an event. It was disastrous. It destroyed villages. It submerged villages. So what sort of event was it? So you immediately start to think, well, you've got the Manila Trench running along between Luzon and Taiwan to the west, and a very active seismic system. There's a lot of earthquakes in that system. But the question is, could that earthquake generate a tsunami? And so what we have here is kind of a reverse modeling exercise where we try to tune the model to see whether we can produce a tsunami that would generate the wave heights. And so in this case, we ran earthquake scenarios. This is a magnitude 8.6 earthquake with uniform slip. This is a magnitude 8.2 earthquake on the right-hand side with non-uniform slip. And we were able to, using purely an earthquake scenario, generate the wave heights to the, to within 20% accuracy of what was recorded in the southwest Taiwan coast. But at the same time, we would generate a significant tsunami. You can see in the left-hand diagram, a tsunami 3 or 4 meters high around Hong Kong and 2 to 3 meters high and around Macau, which is an area that was still pretty densely populated at those times and has no historical record. So it's impossible to generate a tsunami that could have made this event without generating a tsunami that would have significant impacts on the southeast coast of China and Hong Kong and Macau. Now, Macau at the time, 1781, would be quite tuned to tsunamis because it's a Portuguese territory, and Portugal experienced a very large tsunami in 1755. So it's unlikely that they would not have recorded this if it was from an earthquake. So we have to think about a different scenario. So in this case, what we thought, well, the southwest Taiwanese coast has very high sediment loads. And here we have very steep topography delivering huge amounts of sediment to the continental shelf and the continental slope. And that slope is very steep, very dissected, and very sediment laden. And so even a small earthquake could potentially generate a submarine landslide. So we implied that you could run a series of models for submarine landslides, and LS2 is probably the most likely location. And it would generate a very locally significant tsunami with wave heights up to 8 to 10 meters in places, but also generate a tsunami that would not be really recognized on the Chinese coast. And so we implied in this paper in 2015, led by my postdoc at the time, Lin Li, that we think that the 1781 Southwest Taiwan tsunami is likely to be caused by a submarine landslide associated with a moderate earthquake in Southwest Taiwan. And so this is an example where we had to start thinking about working with geophysicists and computer modelers and people who study bathymetry to try and put this story together. We also had to work with historians because the information was in 3 different languages. So it was in French, it was in Chinese, and it was in Cantonese as well, in Mandarin and Cantonese. So there was very disparate data that we had to pull together to make this paper. And so the idea here is that the historical data sets can be really important to try and set the context and the boundaries for which you may want to try and reproduce events. And so in Indonesia, there's a very long history produced by Stacey Martin recently of and Aaron Meltzer and others of historical earthquakes that can be compared to this sort of catalog. And so there's still a lot to do in Indonesia on historical events, including one in Sulawesi in the 1960s that has recently become an area of investigation. So we were able to do this, and we said it was probably a landslide. But the question that we came up with is this is where I want to make this point, that when you start studying a topic and you start to attack a scientific question, first was how many historical events have occurred in this part of the world in Northeast China. And then the next question is, oh, hang on a second, we found a big event in 1781. What caused that? Or it might have been a landslide. But to do that, we had to do a lot of modeling of tsunami models. And we realized that the tsunami models we had back at that time, this is about 2010, 2012 that we started this work, weren't very good. And so we had to improve them. And so what we're looking at here is Manila Trench tsunamis. And so we wanted to look at slip models because the slip models that we had, and these are the slip models that you get for actual events. This is a slip model for the 2004 Sumatra and Andaman tsunami, the 2010 Mentawai tsunamis by my colleague Emma Hill, and the Tohoku 2011 tsunamis. And you can see that something very common through here is that the slip pattern is heterogeneous. There's no block slip. And so what we thought was, if we're going to make more meaningful contributions to tsunami modeling, we should move from models like this, which are very simplified block models of uniform slip, where you're essentially just taking a rectangle of material seafloor and moving it upwards in response to an earthquake to generate a tsunami. And you can see there's a long history of these sort of studies in the northern part of the Manila Trench. And I don't know what Emil Akal was doing in 2011 with that yellow diagram second from the left, but clearly we can do better than this. And so what we produced was a model that you could see on the right-hand side here. We ran uniform slip models, which you can see in the center image. And then we ran a model that simulates non-uniform slip. And so you can see it running around there in that animation. It bounces around. We created 100,000 synthetic earthquakes, generated them above 7, and then modeled the tsunami waves for each of these approaches. And my friends from Geoscience Australia did this for Australia as well and for Indonesia. And so we now have this movement to non-uniform slip models, which, although they're computationally more expensive in terms of the amount of computational time and power they need, they do give you much more accurate estimates for tsunami. If you could mute, please. Thank you. And what we found was the uniform model underperformed the non-uniform model. And so there was probably an underestimate of Manila Trench tsunamis based on the uniform and non-uniform model. Now, the next thing I want to talk about is, what do you do after you publish one of these studies? We published this study. It ran for a while. We had another paper where we evaluated sea level rise and tsunamis together for Macau, which was published in Science Advances. But these models need to be continually updated. They're never going to be perfect. And I was interviewed this morning for an upcoming documentary on the 2004 Indian Ocean tsunami. And I said, there's no such thing as a perfect tsunami model. We have to continually tune them and continually improve our understanding of tsunami modeling so that we can get better at examining the probabilistic effects of this. So a few years later, we published another paper in 2019, which is an updated revised earthquake sources for the Manila Trench tsunami hazard assessment in South China Sea. And we've just started to do some similar work in Indonesia, where we're trying to re-examine the potential tsunami risk based on these non-uniform slip models. So that's the first part of thing I wanted to talk about. The importance of questions being asked in a scientific context, and then the idea of going back and trying to correct things that you identify as you're going along answering a question. So we realized when we were doing the Southwest Taiwan tsunami work that we needed better tsunami models. And so that's exactly what we did. And so we published this one in 2019. That was the last one. I want to move away from that now, and I want to go back to this image of the Palu tsunami in Indonesia in 2018, because we did two things here. A lot of groups went in there. I was there a couple of weeks after the event, and I really wanted to look at two things. I didn't really want to do the modeling because there were a whole bunch of other groups that were doing bathymetry and modeling, but I wanted to look at the sediments, and I wanted to examine this question that you can see in this image here, that the tsunami damage doesn't go that far from the coast. And even though if you look at the videos of the tsunami arriving at the coast, you're talking about a wave that is 3, 4, sometimes even 5 meters high, it didn't have a lot of inundation power. And so I wanted to see whether the deposits actually showed that. And what we've done is use sediments and environmental DNA. And I'll come back to that because that, again, is that message of collaboration. So a little bit about the earthquake. I've got Siam Siddique's paper from the IGDRR paper in 2019 as the tsunami heights. The tsunami was quite significant. We had tsunami heights of up to 5 to 8 meters in places. We have 4,000 deaths in total, but very few people died from the tsunami. A lot of it was due to landslides and damage in buildings. But the issue is just exactly what happened that day. And you can see in the bottom right-hand corner is a screenshot taken from the car park of the tsunami arriving in Palu City. And you can see it's still a very big event with significant power behind it. And it arrived very quickly. And this is because it's now been shown very clearly that the majority of the tsunami was generated by submarine landslides, multiple submarine landslides, sometimes arriving only just over a minute after the earthquake shaking had stopped. And so very little time for evacuation. One of the things we said very clearly straight after this event is that the earthquake is the tsunami warning. And if you feel an earthquake and you're at the coast, you should move away from the coast as soon as you feel safe. And I think that's a message we have to keep reminding people that anywhere in Indonesia, no matter what the tsunami warning situation is like, if you feel an earthquake at the coast, you should move inland as quickly as possible and move up as quickly as possible. So the question I want to ask is, what do the sediments say about the tsunami? And so we collected a lot of sediments with our friends from Kuala University to look at what the sediments actually say about the tsunami. And so we were looking at very contrasting sedimentary environments. I like to examine the whole spread of sedimentary environments. So on the east coast, near Loliage, we have essentially sand here. This is the tsunami deposit sitting on sand. So you have sand on sand. So there's very little distinction in terms of grain size and characteristics, except there's more carbonate in the tsunami deposit of these deposits here on the west coast around Loliage, where we have tsunami heights up over 6 meters. In Pantaloan, we had a longer transect, goes all the way up to the main road. Tsunami sediments in that part of the town were up to 5 to 7 centimeters thick, but generally quite sandy, but quite thin, slight mud component, and I'll come back to that in a moment. And then in Palu City, we have what's called a hotel and the school transects, where there's a damaged hotel, and we took a transect of sediment samples there, and also on the school transect as well. So on the school transect and the hotel transect, which are located here in yellow, we had tsunami heights of 2.5 meters, inundation around 250 meters, sediments found about 200 meters inland. The school transect's a bit longer, tsunami height was a bit bigger, inundation about 300 meters, sediments about 275 meters. But when we talked to the local people here, they were saying that the tsunami height was in the order of a few tens of centimeters, and they were able to walk out of their building and through the water to safety and to inland. So this is, the tsunami is spectacular on this coast, but you can see that the tsunami height drops off very, very quickly. And so it actually kind of broke as a normal ocean wave at the coastline and didn't have much power to it at all. So in the sediments, this is the damaged hotel. We took sediment samples. So this is a younger, thinner me sampling this. And this is also, we took samples of blocks. So we could do concrete blocks. So we could do some boulder modeling to see what sort of velocities you would need to move these concrete blocks. And so we wanted to use both the sediments and the blocks to try and come up with an understanding of what happened in terms of velocity as the tsunami made landfall went across the coastline through coastal ponds like this one here. Now, this is quite a complicated diagram. If you're interested in tsunami sediments, I suggest you click on this link and get Jen Majewski's paper from last year in Marine Geology. But I can tell you that, like, on the hotel transect, the tsunami height drops off very quickly. The tsunami deposit thickness drops off very quickly. It goes down from about a maximum of 8 centimeters down to just only 1 centimeter or less than 1 centimeter, about 250 meters inland, 275 meters inland. And the material is mostly sand. And so the tsunami deposits are in yellow. The pre-tsunami deposits are in brown. And the tsunami is significantly coarser than the underlying sediments until you get into the most distal part of the deposit, where there's not much sand left and it's mostly mud. And so that inverse relationship is there. If we look at the schools transect, it's a similar story. It's a bit more dispersed in terms of the thickness of the tsunami deposits, and the tsunami deposits and the underlying deposits are quite similar. And so they're mostly fine sand in terms of the material, but Pantaloan is a bit different. So here we have coarse sand moving through to fine sand. There's a fining inward. It's much more traditional. They get thinner, they get finer, and they come back towards the underlying sediments. And so this in Pantaloan is a much more traditional setup of what a tsunami deposit would look like. This has probably been affected by anthropogenic effects because it's a very urbanized area. But if you want to have a look at the more details, please have a look at Jen's paper. Now, in the Pantaloan transect, because it was a bit more traditional, we were able to run a variety of analysis. And here we have both the hotel, the school, and the Pantaloan. We used the Souflin modeling data of Robert Weiss, which takes the sediment data and the boulder material. And if we just look at the Pantaloan plot in the bottom right-hand corner, here we're talking about the deposit thickness and the velocities that are needed to move this material. And you can see that the velocities are down less than 10 meters per second. For most, the flow depth is quite low and the elevation is quite low. And so the velocities are not very high to move this material. And so what it means is that the tsunami in all of these locations dissipated quite quickly when it came on shore and lost a lot of power. And so it was quite unusual compared to a normal fault-generated or earthquake-generated tsunami that has a longer wavelength and a lot more power. It was what I would consider to be a relatively weak tsunami. Now, I did some work previously on tsunami deposits. And so in 2023, we published this paper here about environmental DNA. So that is the DNA that is left behind in the environment following the tsunami deposit being laid down. And we compared tsunami deposits and storm deposits in this paper by Wen-Shu Yap in Communications, Earth and Environment 2023. This paper here is pretty much the first direct comparison of storm and tsunami deposits using environmental DNA. And then we published a second paper in Marine Geology in 2023 in tsunami deposits only in Thailand. And this paper on the right-hand side here is very specific to tsunami histories. And so there we have a geological history going back in time, and it gave us the opportunity to think about how long the environmental DNA signature stays in the system. So if you're interested in environmental DNA, and if you are interested in environmental DNA, I do encourage you to work very closely with microbiologists because it's quite a complicated topic. As a geologist, it's taken me years to try and understand it, and I'm still by far from being an expert. But these two papers give you a pretty clear insight into the use of environmental DNA. Now, what I wanted to do in Palu is to take the tsunami deposits that we had from the coastal sequences and in the 3 locations and extract the DNA and then target it and sequence it to identify what sort of community differences there were. And so this is using the approach that Wen-Shu Yap pioneered in this paper in Communications, Earth and Environment to look at the sediments in Palu. And so we looked at the environmental DNA in Loliogi and Pantaloa in particular, because we did have a few samples from here, but they weren't very clear. But here, I wanted to look at this because we had there's very little difference in the sediments. And so in Loliogi, we have sand sitting on sand. So the question would be, is there an environmental DNA signature in that tsunami sand that is not in the material below? In Pantaloan, we have sand sitting on mud and soil. And this is, although slightly sandy, is probably going to have a very different DNA signature. So the question is, can the environmental DNA tell the difference between these sediments without looking at anything else besides environmental DNA? And in both locations where there's a clear contrast here on the Pantaloan site and a not so clear contrast in the Loliogi site. And so this is new work. We haven't published this yet. So here we have the mean grain size and the sorting. There's not much difference between the mean grain size in fire. It's much coarser sand for the Pantaloan example. And you can see the underlying sediments are much finer. There's not much difference in sorting. And then as you go inland, the difference between the tsunami deposit and the underlying sediments are much smaller in terms of the grain size. And so here we have basically sandy mud sitting on top of sandy mud. And so there's not much contrast. Now in Loliogi, we have fairly coarse sand sitting on top of fairly coarse sand. In this profile here, Loliogi 2, we have pure sand. It's the tsunami sand and the underlying material is almost identical. And we don't have many samples because sampling for this can be quite laborious, and you have to put it in -80-degree freezer. And so you run out of room very, very quickly. But the question is there a difference between the underlying samples, these samples here in the green zone, and the overlying samples in yellow? And the answer is yes, in all 3 locations. And so here we have in the triangles are the tsunami deposits from Loliogi, and here is the 2 underlying beach deposits from Loliogi, and there's a clear distinction between them. And this is a separation technique that you can find out about in Wen-Shu's papers. I won't go into too much detail. And again, here we have a clear distinction between the Pantaloan tsunami deposits, and it's not as clear the underlying material. And then in Palu City, they only have 1 sample, and there's a very clear distinction between the underlying soil and the DNA. So we are quite confident that there is an environmental DNA difference between the tsunami deposits and the underlying sediments. And the idea is now that you can use environmental DNA to go back several thousands of years. I know some of my colleagues are doing this in a cave in Aceh. Others are looking at potentially precursor tsunami deposits to the polar samples. And so environmental DNA is a new tool that is quite interesting. And it goes back to that theme. The theme that I wanted to run with this whole time is that geoscientists who want to get at a better understanding of coastal hazards like storm surges and tsunamis need to work with people outside of the geoscientific profession. You need to work with historians. You need to work with computer modelers and engineers. And you also need to potentially work with people like environmental microbiologists. And so that's the case with this one. I think I'm pretty much out of time. So I'm going to wind it up now. The conclusion on Palu is that the earthquake was generated a compound tsunami from submarine landslides. The tsunami deposits were varied, but they generally thin, fine landwards. The environmental DNA showed up in the multivariate analysis that it's pretty clear distinction. But they do have a hybrid signature with both storm and tsunami deposits. And so it's likely that the tsunami itself had a short wavelength, relatively low power and short-term inundation. And that means, and limited availability of nearshore sediments, you get thin deposits that don't go very far inland. And so the question is now, if you go back and start looking at the paleo record in Palu, have you had similar types of events? And whether you can find the tsunami deposits onshore or whether you can find the landslide deposits offshore, that's the only way to really start to dig into this. On my initial question, I think I think we're really in a situation now where the next generation of Indonesian scientists, geoscientists, we need to all think about, it's not just a geological problem. Collaboration and interdisciplinarity. And, I've got examples here of working with historians, statisticians, and biologists to try and pull this together, because if we want to answer this, it requires detailed analysis of each event using these multidisciplinary techniques. And by collaborating, I think is really the only way that as geoscientists, we're going to improve our understanding of coastal hazards. Okay, I think that's where I'll leave it, and I will turn off and take questions from the audience. Thank you very much.
Okay, thank you, Adam, for your great explanation about getting the long views on coastal hazards, particularly about the tsunami generation in Southeast Asia. From what you mentioned just now, to getting the long views of the coastal hazard, it is not the short-term description. It's like collecting the historical data, and then from that we can modeling the recurrent interval of the event. And then you also mentioned that to get the knowledge about the tsunami hazard, not only from the geology, but also from the geophysics, and then geologists, then oceanography, computer sciences, and then they integrate the knowledge and then study the history, and then make the predictive model for the recurrent. Because also, I think from the previous events of tsunami in Indonesia, we can learn that the 24 we learn the tsunami can be generated by the earthquake or the tectonic. And then from 1883 and then 2018, I guess, we learned that tsunami can be generated by the volcanic activities. We learned from Krakatau and Anak Krakatau. And then from 2018, we learned from Palu, the tsunami can be generated by the landslide, or also from a landslide. And then there are many things actually you mentioned just now. We already have a participant. We want to ask a question. Please, Bapak Ilham Alimuddin.
Can you hear my voice, Pak
Yes,
Saad?
Pak Ilham. Yes, Pak Ilham, please.
Thank you very much. Good evening, Adam. It's really nice to listen to your explanation on this specific research on the sediments on Palu. We heard a lot about Palu earthquake and how it occurred with all disasters, earthquake, liquefactions, and all those sort of stuff. But this is interesting because you're looking at a different perspective on geology, not only looking at the structural, how it happens, because Palu really taught us something related to geology, that not all this earthquake can directly created the tsunami. The tsunami in Palu, actually, we learned that it's because of the landslide. Now, the question is that you are studying the sediments that coast into the land. I mean, I was thinking of having this study later. We can actually learn also that potential landslides along the coast of any possible that related to earthquake in the future can also created this kind of model, right? So my question is not only not only studying also the source of this material, you know, like you discovered how the fines, particles, sands, etc., which we believe that it comes from that landslide from the offshore, right? Just along with the coastline of Palu shore. That's what my curiosity. I said, why not also looking at the history of the deposits along those shore of that was generated by the earthquake? That's first question that you can comment on. Second is related to the power of this, because it still created victims, you know, the tsunami, although it's not that many as the Japan 2011 Sendai. Because I was there, Adam, I was doing my PhD in Japan when it happened. So it really can give us the different situation of Palu and other tsunami like Aceh as well. So those two questions probably you can comment on the sediments. Really nice on learning something. I hope one day you can come to Makassar with Saad. We're waiting for you.
I'm coming in November.
Okay. Yes.
I'm coming in November.
So hopefully we'll be meeting you then.
Exactly.
Yeah, I am the partner with Saad in the geological department of Hasanuddin University, Adam. Nice meeting you. Thank you. If you can comment on these two questions, I'll be happy. Thank you. Thank you, Adam.
Okay. Please,
let me comment on the first question. The first question relates to the history of tsunamis and how can we use the geological archives. You know, one of the things that we thought about when we were in Palu is, you know, are there locations in Palu that are going to record the previous tsunamis? And the answer is almost certainly yes, but they're not easy to find. And we had very clear scientific objectives with our exercise to examine the modern deposits. And so there's still the chance to go back and look at the onshore deposits. Now, the question also relates to the landslides. Now, the submarine landslides would generate deposits in the deeper parts of the basin as well. And so there should be, in the marine archives, also layers of turbidite associated with the landslides. And so coring the deeper parts of the environment and looking at can also probably give you an archive as well, because has been very heavily modified. And so it's very hard to find any geological archive in the coastline that is not heavily modified or has been heavily eroded. You know, on the west coast, you've got gravel and sand mining. On the right, on the east coast, you've got a large number of people living there. And Palu City itself is built on, you know, mostly reclaimed land. So we had difficult archives to try and deal with. But offshore, you might get a more success story. On the next question, this, you know, when like the inundation in Aceh, Oku, that plane, we're talking half. So for this event, I was quite surprised that wavelength, the tsunami, although spectacular coast, and yes, quite damaging for the first time, all the way along around 150 meters inland, that the tsunami height was only about knee height, and that it wasn't moving very fast, and they were able to walk through the waters. And so I remember talking to Herman Fritz from Georgia Tech about this, because it's very different. The Palu tsunami is very different hydrodynamics at the coast than something that has a much longer wavelength that has come from a long distance. And so it behaved much more like a normal crashing surf wave. Still damaging, but lost a lot of power by the time it had got about 100 meters inland. So there's still a lot to do in Palu. And we have ongoing projects. in Sulawesi at the coast and also in the lakes, because some of the lakes also potentially have tsunamis in them as well.
Okay. All
Plenty to
right.
do. I
Thank
can't
you
wait to
for.
get there in November.
Sure. We'll have a longer discussion later when you come to Makassar. Thanks, Adam.
Okay, thank you, Pak Ilham. Is there any participant want to ask directly? Mr. Daniel Setio Wicaksono, you can ask, raise your hand, and then there is a question, Adam, in the chat box from Daniel Setio Wicaksono. So he said that I'm very curious about getting the historical record of the geohazards. What kind of source can we cite for such event? Because here in Indonesia, we had a lot of old texts, and some of them sometimes record some such hazards. So how do we confirm that valid or not?
Yeah, this is a question that comes up a lot, particularly when it comes to indigenous cultures and indigenous records. Some things are down. Sometimes they're passed down as old traditions. Sometimes they're in poems. Sometimes they're in songs. And this is a conversation with people that work in sciences. I think the local archives in Southern Java, for example, I think, is it Babads? Is that what it's called? I think that's it. I can't remember what it's exactly called. But the government, local histories that are around that flooding event in South Java that could well have been tsunamis. But as you go back in time, these can get vague and the descriptions can be quite crazy. I know in the Australian context, there are indigenous records where they describe the ocean roaring like a dragon and flooding the landscape and being angry with the local people. From record 1800s, you might get something that has a bit more detail. So we just published a paper recently in 1921 cyclone. We were using the fish inspectors data. And so, this is a letter written and a notebook written by an inspector who went around and wrote things like, by midday, the water had reached the top of 3 feet above the top of the pier. So you know the time, you know the height, and you know the exact location. And so you can start to reconstruct things. And that's what we did in Taiwan. But in Indonesia, I haven't found very clear historical records. A lot of them are quite vague. And so you really do need an expert in the sort of ancient scripts to understand it.
Can I comment on this? Because we have Lontara in Sulawesi, and this is similar to Babat. So I know their professor is working on this script, trying to discover on what the inscript of that Lontara that tells about the event of disaster, like how they see the volcano eruptions of the Tambora, for example, or others. We are also working on this with the expert of Lontara and see the ability of history. But other than that, I would like to mention about how some of our researchers, also in geology, are trying to look at the older sediments on coastal areas, Adam. I know one of my fellow researcher are doing this. We're looking at some of our beaches and looking at the history of tsunami from the accumulation of sediments on the coastal areas. That would be also scientific measures on how the history of tsunamis in the past, right? Yes, just to comment the questions.
Yeah, there are so many records, and I people trying to decipher the Babads, particularly for Southern Java, because I think they're pretty clear into archives of them yet that show the repeat tsunamis in the southern coast of Java. And we haven't done it for either. And so, yeah, environment be very, very interesting. And, I think that's one of the primary reasons that we're going to take this, this new collaboration with Makassar forward.
Okay, Adam, thank you for your question. From Prof, your answer from the for the Daniel's question. Is there anyone who want to ask about the tsunami generation, the validity, and then about the long view of the coastal hazard? Okay.
Everyone's getting.
Actually, to add your answer just now also, because for example, the history of the tsunami generation in the in Gamalama, for example, we got the the diary of the King of Ternate at the moment in 1640, and then he described about how the earthquake happened, and how the volcanic eruption there, and then how the sea or the Molucca Sea, the wave there. So it's kind that we can use for the validation or to make sure that it's really happened at the moment. So the question is, can we use also the approach for the other coastal hazard, Adam? For example, the storm surge or flood.
Yeah, one of the things I've been working on with my friends in environmental history is that coming up with a methodology of validating events. If you've got multiple records that state the same sort of thing around the same time, can you give that more validity than, say, something that is only a single event, a single record that perhaps may not have the same sort of accuracy or same sort of description? And so we did this for the storm surges in Western Australia, where we looked at cross-checking the historical sources against each other. And in a way, that paper that Annie Lau read was the same sort of thing.
Okay. Thank you, Adam. Is there any other question from the participant? If not, maybe I can sum up from the discussion. So from the topic that you delivered tonight, from the long view on coastal hazard, it needs the integration. We collect the historical data and then we use it to make the predictive modeling. From that, we can result in the more comprehensive view of the risk that can involve. And then we can use it to protect the coastal ecosystem and communities. Following that, we need to improving our understanding. From that, also we can use it to model the potential tsunami, which can happen in Indonesia, particularly, for example, in Sulawesi area. From Solofip and Go, there is the catalog of tsunami. We can see the history tsunami in Indonesia and Pacific, particularly in eastern part of Indonesia. And also from Rafael Paris, Yon College, from he mentioned several volcanic tsunamis event in Indonesia. I think that's all for this tonight session. I will give to the MC Master of Ceremony, Tarania.
Okay, thank you, Mr. Saaduddin, for the moderator for this evening invited session, and also to Professor Adam as our honorable speakers tonight. We appreciate your valuable insight and guidance. So as we move forward, we will now be ready to take photos together. So for all the attendees, please kindly turn on your cameras. Thank you. Okay. It sounds like we are all now ready. So let me lead us in this photo session. Okay, let me count to 3. From 1, 2, 3. Thank you. Maybe once again. 1, 2, 3. Okay, thank you. Thank you, ladies and gentlemen. So
Thank you.
Thank
thank
you.
you.
Thank you, Adam.
Please
Alright,
don't forget to fill
terima
out
kasih.
the attendance form using the link provided in the chat box. Or you could also scan, maybe the operator, can you help me to show out the screen? Yes, please remember to fill out the attendance form using the link provided in the chat box, or you could also scan directly through your screen to claim your certificate of participation in today's VTS session. I would also like to invite and kindly remind you once again for our main event, the 53rd IAGI Annual Scientific Meeting, Convention, and Exhibition, which will take place in Balikpapan on 7th to 10th of October 2024. And for further information, please revert to the details displayed on the screen below. Don't miss out the event and don't forget to register. So as we come to the end of our presentation and discussion session with our esteemed speaker this evening, I would like to express our heartfelt gratitude. Thank you once again to Professor Adam and Mr. Saaduddin for joining us and sharing your insightful and educational presentation. Your contribution have undoubtedly enriched our experience today. And I would also like to extend my sincere thanks to all participants who have attended today's event. Your presence and engagement have made this gathering all the more meaningful. My name is Tara, as your MC for this virtual technical section. Would like to take my leave. Thank you to all our esteemed attendants for your active participation. Wishing you a pleasant evening. I will look forward to seeing you at the future meetings. Terima kasih dan sampai jumpa.
Bye-bye.
Thank you very much, Mr. Adam and Mr. Saaduddin.
Thank you,
See
everyone.
you in another session.
Terima kasih Pak Prof dan Pak Saaduddin dan adik-adik panitia.
Terima
Izin
kasih
leave.
Pak Hamzah.
Terima kasih Pak Ilham. Terima kasih Pak.
Ya, mohon maaf
Sampai
ini
jumpa di
belum.
Balikpapan.
Ya, sure.
Semuanya.
Bye-bye. Izin live ya, Pak Sat.